Hello, everyone, and welcome to today's webinar. Today, we will look into how you can use WEkEO data to study land use and land use change. My name is Andrea Carvalho. I'm a training officer at Mercator Ocean International, and I'll be your host for today. So before we start with the content of this webinar, we will go through some house rules and how we can better enjoy this webinar. So let me just give you some few guidelines. So if you're connecting and you're following this live, you probably noticed that you have to access the audio on your bottom left corner. You had to activate it. If you haven't done it yet, you're seeing this slide and you probably realize that you have to do it. Also, there's a chat tab on your right-hand side of this live streaming area. Where you will be able to post some comments or small questions if you want. If you have any technical issues, you can also use this chat for that. But we do recommend you to use the Q&A section that you will see at the top of your page. There's going to be a bar where you're going to see Q&A, and please use this Q&A section for any questions related to any presentations we're going to do today to any of our speakers. And in the same area, you will also find the survey that we will share with you at the end. We really appreciate your feedback on our sessions. So yes, later, more on this later on. And now I will introduce you to the agenda, the program we have for today. As I said, we will be looking into what WEkEO can provide in terms of land monitoring studies. So as I said, I will be your host for today, and I will also give you a short overview of the WEkEO service and the products you can find. And then we will have three very interesting use cases. So three examples, practical examples on how you can use WEkEO data to study land changes, agricultural land, urban projects, and so on. So we will have David Parastatidis from the Remote Sensing Lab. We will have Francesco Vuolo, a senior scientist and representing the project BOCU, and David Garcia Alvarez from who's an assistant professor at the University of Complutense in Madrid. Okay, and now we can jump right through what is Copernicus service. And so the WEkEO, what is WEkEO service? So WEkEO is a GIS, or a data and information access service. It was basically created to facilitate the access to Copernicus and Sentinel environmental data. In WEkEO, what we offer in WEkEO is, as I said, a facilitated access to environmental data, but also cloud infrastructure and very complete user support. WEkEO is operated by the different entities that are entitled to manage the different Copernicus services. If you haven't heard of Copernicus, it's a European Union's program dedicated to Earth observation and to monitor the Earth. We have different entities that are responsible for the different services. We have 6 services in total. The land, the climate change, the emergency monitoring service, the atmosphere, and the Copernicus Marine Service. And besides, we also have some Sentinel missions, or Sentinel are the satellites that provide the data that you can find in Copernicus, and they also have some missions which data you can also find in WEkEO. So how can you access WEkEO? Through its website. WEkEO.eu, you will be able to find a catalog with products. You will find more information on computing resources. You can find use cases. You can have a list, as probably you have explored it already, on how to access the events that we organize and many other materials I will be mentioning to you later on. So the three main points of WEkEO and why is it an advantage is that it provides direct access to the Copernicus, all the Copernicus services data, which is directly linked to the original sources. So it is not a copy. And this access is also harmonized. That means that facilitates some programming or an analysis that you might need to do. Might need to do with that data. Besides that, there's also a user support, very active user support, which you can always contact and ask any questions you have related to the data, to accessing the data, etc. So as it is the case for any Copernicus delivered data, the access to WEkEO is also free. The access to data, to download the data is also free of charge. It's open source data, environmental data, which we provide. And we also provide free access to e-learning materials, which are in a format of, for example, Jupyter notebooks and etc. And then we provide a section that if you're, for example, more experienced and you would like some computing power, that is a part that we apply a cost to it. And but for the rest, to visualize, to access the data, that remains free and open to everyone. As I said, you also have access to a Jupyter lab. So if you have heard of the Jupyter and Jupyter notebooks, this is a nice way for you to learn how to use the data, how to do basic analysis and kind of track your evolution, because we share it through this Jupyter environment. And you can learn a lot through this platform. So for that, you can also access our Jupyter Notebook gallery, which you will find a lot of Jupyter notebooks already developed in different, focusing on different services or the use of data from different services. So as I said, you also have access to virtual machines. I will not go into that much today. And so don't hesitate if you have any questions related to any data. Yes, it's very easy to contact the user support. You can either do it via email or through the help center that you will find on the website very easily. And now in terms of the products you can find, what is provided in WEkEO, I will go through a short overview of what you can find in there. So as I said, you will find data related to or coming from the 6 different Copernicus services and also satellite missions. For example, if we start with the first one, the Copernicus Marine Service is operated by Mercator Ocean International. And the goal of this service is to monitor the marine environment. So you will find data related to the blue, what we call the blue, the green, and the white ocean. So the blue ocean would be more the physical properties of the ocean. So things like temperature, salinity, currents, waves. Green ocean would be more the biogeochemistry component. So nutrients, carbon, plankton, phytoplankton, and so on. And the white ocean would be the ice concentration, ice thickness, ice temperature. The Copernicus Marine Service provides different types of data. So data coming from in situ, so direct measurements, but also satellite observations. And then they also use this data, these 2 types of data, to validate some models and improve the estimates and produce forecasts into 10 days into the future. And in terms of geographical coverage, it covers not only Europe, so the different basins, as you can see in this slide, Arctic, the Baltic, the Northwest Shelf, the Iberia, Biscay and Irish Seas, the Mediterranean Sea and the Black Sea, but also the global ocean. So in terms of data we provide, you can have satellite, as I said, satellite observations, L3 and L4 levels, in situ data that are can be collected from different vessels. You have research vessels, but also buoys, Argo floats, etc. And then this is all assimilated or injected into numerical models, which help us to have a clearer idea of a 3D component. If we go to, if now we go and talk about the climate change and atmosphere monitoring service, and also the emergency management service, which are all operated by ECMWF. So if we talk about the climate change service, the goal is to monitor the climate in the past, in the present, and the future. It also provides data in situ, type of data, satellite and models, and they range from different temporal and geographical coverage. Here you have just a few examples of the variables you can find from each type of data. And also these direct observations are used also to produce reanalysis, forecasts, and even projections in very long term, normally in many years in the future. For the atmosphere monitoring service, so the goal is to monitor, for example, the air quality, the solar energy, and the role of the atmospheric gases and particles. Again, they also provide in situ satellite and model data with using different sorts of instruments and different techniques. For the emergency management service, sorry about that. For the emergency management service, the goal is to monitor man-made and also natural disasters, and create alert systems to better mitigate impacts in society. So in WEkEO, well, so as you can see, there are two main different types of data that you can find in the emergency management service: on-demand mapping and early warning and monitoring. However, on WEkEO, you will only find data related to floods forecasting and fire. So the study of the impacts of fires and near real-time fire activity. Related to the floods, you will find data related to river discharge, for example, at different geographical coverages, as you can see, and also temporal coverages. In terms of fire dangers, you will see you will find parameters such as the burning index, danger rating, fire danger index, fire weather index, initial spread index. And now maybe the service we will hear most about today is the Copernicus Land Service, operated by the European Environment Agency, which goal is to provide geographic data on the monitoring of the land surface. So the main products you can find that are provided by the land monitoring service are related to vegetation, energy, water, the cryosphere, or the frozen parts of the earth, and hotspots, which are key areas that are considered with a high risk on the globe and ground-based. So in terms of vegetation, these are just a few examples. You can find vegetation properties, vegetation indexes, dry matter productivity, burn area. In terms of energy, you can find land surface temperature, surface albedo, top of canopy reflectances, which, for example, in this case, they represent the energy that, or the sunlight that is reflected by the surface of the Earth. In terms of water products, you can find lake surface water temperature, lake water quality, water bodies, water level. In terms of ice, you can find lake ice extent, snow cover extent, snow water equivalent. Hotspots, there are also some information related to different areas of the globe. So urban, river areas, Natura 2000, which include more ecosystem classifications, natural biological classifications, and coastal zones, and ground-based at a global and European level. So in this case, it provides multiple years of high quality in situ measurements which were used to validate geospatial land products and products like land cover and land cover use from also other satellite products. And then at last, we have the Sentinel missions, which are operated by EUMETSAT. And there are a few satellites active and that are constantly providing data for all the Copernicus services, and for that you can find as well in WEkEO. I will not go too much into this part, but just to let you know that you have Sentinel-1, which is, you can use the data provided by Sentinel-1 for example, monitoring sea ice and icebergs, river and lake monitoring, support on emergency management such as floods and earthquakes. So you will see the applications are quite varied. The Sentinel-2 can use it in agriculture, land ecosystems monitoring, forests and management. Yes, and Sentinel-3, which provides not only ocean color, but also sea level data. So you can see type of applications are measuring sea and lake surface topography, sea and land surface temperature, but also sea ice and land ice elevation, and ocean and land surface. And at last, Sentinel-6, where types of applications that have been used are, for example, on ocean currents, wind speed, and wave height. And yes, I think that's all on the types of products you can find in WEkEO. This was a very short overview. We will hear a little bit more about the products that you can find through our use cases. And so first, I will introduce, so don't hesitate if you have any questions. Later on, we will address the Q&A moment for that. And now we will introduce our first speaker, who's David Parastatidis. David, if you're there. Yes, perfect. So the floor is yours whenever you want. So David Parastatidis from the Remote Sensing Lab, who's going to present integration.
Can you hear me now?
Yes.
Okay, thank you.
Loud and clear.
So, hello everyone. Thank you for the invitation to the workshop. I'm David Parastatidis. I am a GIS analyst and full stack developer at the Remote Sensing Lab in the Foundation for Research and Technology, Hellas. Our lab's main focus is on the climate change and urbanization and the many different ways these two impact each other. Today, I will present to you one of our Horizon 2020 projects, the CURE, which stands for Copernicus for Urban Resilience in Europe, and how we integrated the WEkEO cloud infrastructure to help us achieve this project's goals. So it is a collaboration of 10 partners with the Remote Sensing Lab leading the project with the aim to exploit the Copernicus core services and develop an umbrella application for urban resilience. There are 6 Copernicus core services, as Andrea said previously, focusing on atmosphere, marine, land, climate change, security, and emergency-related data. In WEkEO, we combine products from 4 of these services, the atmosphere, the land, the climate change, and the emergency. And we introduce new ideas on how to develop applications across these services in the domains of climate change adaptation and mitigation, healthy cities and social environments, and energy and economy. During the progress of WEkEO, we continuously interacted with users from its case study city, which, as you can see here, were Berlin, Copenhagen, Sofia, Heraklion, Bristol, Ostrava, Basel, Munich, Vitoria-Gasteiz, and San Sebastian. We organized workshops to gather user requirements from businesses, scientific and urban planning communities. So after extensive dialogue, we analyzed these user requirements in order to provide the WEkEO applications tailored to their needs. So in WEkEO, we developed an umbrella application, the WEkEO portal, which consists of 11 individual cross-cutting applications. The applications focusing on the heat variable provide products related to the local scale surface temperature dynamics, the surface urban heat island, the urban thermal comfort, the urban heat storage, and the urban heat emissions. We have applications related to hazards and risks, the urban flood risk application, and the urban subsidence movements and deformation risk application, and applications focusing in the CO2 emissions, the air quality, the nature-based solutions, and the health impact from various variables such as the air quality. You can find everything related to the project in the WEkEO website. You can scan, of course, the QR code in the slide or follow the URL. Along with information for the project, you will also find there the WEkEO portal, as I mentioned, which contains all the 11 applications. Now I'm going to show you some of these applications. Yes, the video starts immediately. Okay. First, we have the local scales surface temperature dynamics application. For each application, you will find a storyboard on the left side that you can scroll, which contains information about the selected application's products, along with map visualizing them on the right. In this application, we calculate the land surface temperature maps for urban areas by combining the Copernicus Sentinel-3 thermal acquisitions, the dynamic information on the land surface from Sentinel-2, and products from the land, the atmosphere, and the climate change from the Copernicus services. Similar maps are available from Copernicus, but at 1 kilometer resolution, which makes it difficult to observe the variations of surface temperature at neighborhood scale. This WEkEO application compensates the spatial and temporal resolution trade-off of the satellite LSD products, providing dense time series of 100 meter spatial resolution LSD with up to 4 maps per day. So on the maps side of the application, you can see on the right the Copernicus LSD, and on the left the WEkEO LSD, where the resolution is much higher. You can change the transparency to have a better feeling of what's below the LSD map, where here you can see the pattern of the urban layer showing on the LSD map. You can also browse different temperature products during the daytime and nighttime. And as we have up to 4 maps per day, you can compare daytime and nighttime temperatures and go to specific dates. And here we also have aggregated temperatures to units such as urban plots, neighborhood block for specific level of analysis. Okay, going next to the CO2 emissions application. In this Cure application, again, we have the storyboard on the left, and on the map we can see the emissions for Heraklion during the whole week. We can select the emissions for the weekend only, or again for the whole week. We can also compare the emissions for different seasons, and also not included in this video, you can compare the emissions from different sources such as the vegetation, the population, the buildings, and the traffic. In this application, we combine data from the Copernicus Land, Climate Change, and Atmosphere Services together with third-party in situ data, such as from ecoviruses that we have in Heraklion. Another application is the air quality one. This Cure application provides information on pollution hotspots in the city and the sources of such pollutions. Here we can see for Sofia the NO2 concentration on the left are observed on the main roads of the city, and the particulate matter on the right. You can set the opacity as well. And you can choose between the total annual mean concentration or choose to see the concentrations coming from specific sources such as the traffic, the residential area, and the industrial area. In this application, we needed to combine data from the atmosphere, the land, and the climate change Copernicus services, along with other third-party local data. Now, to show you one of the hazards and risks applications, the urban flood risk one. Here you can find information about the flood risk for individual land use sections in urban areas, as well as the total area of flood risk per land use class. Also, the application provides maps for flood hazard zones. All the maps were produced by combining only Copernicus products from the land, the climate change, and the emergency Copernicus services. So this makes this application very easily transferable to other European cities. One last application, as I don't have the time to present all 11, is the nature-based solutions one, which provides maps of building roofs with the potential of becoming green roofs based on their physical parameters. It also provides maps for green roofs priority based on the benefits and the impact they will have on reducing the urban heat island. The application, as we see, we'll see further in the video, yes, here, provides quantitative data for the total area of green roof potential in the city. So by providing such visual and quantitative data as shown in all these applications, they can be a great tool for authorities to support the decision-making for sustainable and resilient urban development, and pointing in the right direction for finding existing or potential vulnerabilities and how to mitigate them. Now, after showing you some of the Cure applications, let's see what's under the hood and how WEkEO is involved in all this. Here is a representation of the whole Cure system workflow, starting from the top, where we have the user requirements which are needed whenever we develop any kind of application in the Cure project. As I mentioned, we were in constant communication throughout the project with the related communities of the cities. the aim was to create the services in the form of these applications, which would provide the information to support their decision making. So in order to provide this information, we start from the input data on the left of the graph, which are coming from the Copernicus services, the Sentinel missions, and from several other third-party services. These data amount to petabytes of storage, so it is impossible to have them stored locally. In our case, we use the Copernicus Core Service Interface, or CCSI for short, to search and find this data in WEkEO cloud repositories. So each time your application is called to generate a product, it first requests the input data that it needs from the WEkEO catalog. For data that are not included in the WEkEO catalog, WEkEO also provides storage where we saved all the data from the third-party services, and we were able to access them from there when needed. Of course, its application in order to process this input data requires computational power and to be operational 24/7 in order to provide the data to users at any time. For this reason, we used WEkEO's cloud infrastructure to deploy the applications there. I won't go into much detail about the individual API calls and the scheduling that is needed for all these components to work together, but I will just mention that all 11 Cure applications are running in Dockers on WEkEO's cloud. So by putting them there, we have faster access to WEkEO's catalog and to the repositories where the third-party data are stored. And of course, we take advantage of the computational power of the cloud server for the applications to process the data in a timely manner. In the end, the end users are able to access the applications through the Q portal as demonstrated in the previous videos and access the data. In conclusion, the expected outcomes of the Cure project were to build an online platform for combining the Copernicus core services to support urban resilience, to integrate the DIAS cloud infrastructure, where we choose WEkEO among the other platforms, create uniform data for urban areas across Europe, gather consistent measurements across European cities, and create synergies with Copernicus core products and third-party data, use different approaches and models to get better information for urban environments and its functions at different spatial and temporal scales, and the assimilation of users' knowledge with technical data and benchmarking. So that is all for me. You can find everything about the Cure project and everything we do in lab through this link. And of course, you can contact us if you have any further questions. That's all from me. Thank you.
Thank you very much, David. That was very nice. And there's a bunch of questions for you now.
Okay.
That project is so interesting that just sparkled a lot of interest. First, there's a few questions on like more general questions. I think that's more for me. I could just in a general response. Yeah, Sentinel 3 and 6 data that it is accessible through WEkEO. They are freely available. Yes, if you explore the catalog, once you enter in wekeo.eu, you will have access data tab, and you will see a viewer with a left-hand corner kind of all the products you can see on your left-hand side, and you will be able to select by type of satellite or by the different services, and you will see that you will find this data there. And in another general question, yes, everything that we are, so the recordings of this session and also our presentations, if our speakers agree with, we will share them with all of you, because it's indeed very interesting. And so more now, if we want to address the questions for you, David. This one did it. Yes, so first one.
Okay, because I was not sure if the previous one was for me or the general data sets. So
yeah.
okay.
Still general. So yes, freely available for everyone. So For you, do you differentiate sensing the temperature of the land itself from the heat emitted by the buildings?
As I was not, the project was big. I was not involved in the creation of the applications and the science behind them. I am not sure if the application heat emissions is providing that, as I was not included this in the video, but you can go and access the application from the WEkEO website as I linked, and of course you can contact us to get you in touch with the developers and go in more detail about its application and the science behind it.
Great. Have you used any in situ data for these analyses, or you have just used the Sentinel data?
Yes. Most of the applications use in situ data. For example, for the CO2 emissions that I mentioned, we use in situ data from ecovariances. We have two of them in Heraklion. We are collaborating with Basel, which they also have towers like that. So this is one example of in situ data, and we combine them with the Copernicus core services data to create the products for these applications. So yes.
For the CO2 emission mapping, are you using land use or land use cover data?
Again, I would also guide you to the application itself, where more information about its application is described, and also you can contact me to get in touch with you with each of the developer. So I won't give you any false information right now. Yeah.
Yeah, thanks. And are the products available for all over the world?
No, these applications were specifically, as I mentioned, for several European cities. The aim was for them to be able to replicate them for the whole Europe using the Copernicus services, which again, of course, are products that are focused in Europe.
Yes, thank you. So have you used, oh, this one we have just responded to. Applications developed by Cure are only available for the cities of the project, but the processes can be replicated through or like using other products from WEkEO. Is it correct?
Yes, this is correct. Yes, you can replicate most of these processes for other cities. Of course, as I said, many of them use third-party local data, and not only the Copernicus core services. So for these applications, you would have to find similar data, but they are applicable to other cities. Yes.
Okay. And I think I saw a question passing by regarding the process being available, like the process being open, like and shared, like how you like the process of Cure, if all of that is open and free as well, so that people can recreate it. Is that shared in the Cure?
This depends for its individual application, as there were many partners and with a different level of openness. And so you have to contact each individual developer. The developers of its application are also mentioned in the website, so you can find them very easily.
Okay. Thank you. And maybe one or two more for you, but there's definitely many more. How to access? How did you access the in situ measurement LAI? And is the system also offering to download Sentinel-2 images for that area where the LAI measurements took place?
Generally, for local data, we used websites from the local authorities, or they were already available from local GIS platforms. Most of them were open for each city, but of course, we were in contact with the authorities if we needed further data. And yes, we could download, of course, the Sentinel-2 images. And in our case, it was not even an issue to download them because, as I said, the applications were running in WEkEO, so we had access instant from the repositories, so we didn't have to download them locally. They were accessed through the WEkEO infrastructure.
And maybe one or two more. In the near future, will the CURE project cover other areas in pan-European region? Is that the plan?
Yes, the plan, we would hope so, to replicate these applications and maybe go further with the continuation of the CURE project to cover more cities. It's in the plans for sure. Yes, we always want to go further with what we have already achieved.
Great. Yeah, I hope we can apply it to other places. That would be super interesting to see.
Most of them were created anyway with this in mind to be easily replicated. So yeah.
Can imagine. Okay, I think we can stop for now and give the floor to our next speaker. Thank you very much, David.
Thank you very much for inviting me.
Yeah. Now we have Francesco Vuolo. He's going to present us a use case learning monitoring products for agriculture. I already saw a few questions, actually. Maybe later on you can answer related to crops and agriculture. Yes, welcome. The floor is yours.
Thanks for the invitation and thanks to all the participants for listening. I will try to give you an introduction on some of the monitoring products that we use for agriculture. In particular, bringing examples from a project and going a bit beyond the project context. A brief introduction about myself. I'm basically a scientist, so you will have the view of a scientist on deploying on big IT infrastructure. And I'm specialized in the use of optical data, so in particular Sentinel-2, Landsat-8. This is a bit my domain of application, looking at problems such as length over, length use, and classification, so a classic of remote sensing, but also going into more continuous variables retrieval. Question was about leaf area index. My presentation might be able to answer that question. And later in my work, also on making such processing operational so that they can be used and we can capitalize on the data, on the services that are there, in particular for precision farming or data-driven farming. I also tell you a little bit about the major milestones that I have gone through my career and how we got to this point. So I started working in this area many years ago already. And the first, I think, big achievement was in 2016 when Sentinel was just making the first rounds around the Earth. We were already able to provide in very short time services for providing atmospheric correction and the level 2A data. And in addition, products such as albedo, leaf area index, looking at agricultural lands in particular. So those were the precursors of what we know today as the diocese infrastructures. And we had a very strong focus on agriculture. We went into providing services for smoothing and gap filling data. We all know problems related to clouds and irregular data spacing. And the users, in our case, farmers, were asking for continuous data stream. Every day we want the data. We don't care about clouds. And we moved then in 2020 with the collection of a bit more advanced algorithm to look at vegetation, doing the monitoring of it, but also the management. And lately, we completed the Koala project, which will be the main topic of the presentation I'm going to deliver today, to implement, test, validate, consolidate a number of products and services that are today available for data-driven agriculture or satellite-based data-driven agriculture. So our projects have been funded by the European Commission with some national funding in the very early stage from I'm based in Austria, from the National Funding Agency for Space Activities. A little bit about the connections between my institution and the WEkEO. So we are, as I said, we are in Vienna. We are primarily an education center, university. We do research, but we also, and we applied research. So as I say, we also work a lot with farmers outside, and we try to develop in their direction to support them. We all know that Sentinel data are offer large volume of data. And many years ago, 2015, I think, we partnered with the EODC, which is the Earth Observation Data Center for Water Resource Management based in Vienna. So this is a big center with a lot of computers, a lot of computation power. And lately, the ODC also became a federated partner with WEkEO, where is providing access to the long-term archive for Sentinel-1 and Sentinel-2. And we know WEkEO, we heard about Andrea, it is the European, one of European Copernicus dioceses. And as I said, I'm going to focus on Koala, which is in all this big data family. It's a small project that looked at how to capitalize on the Sentinel data, Sentinel-2 data, to provide services for agriculture. So Koala, because Koala was mostly implemented in Australia, and we work with the partners over there to provide services. So the classic products for land monitoring, this has already been introduced this morning. So there is a land monitoring service where we have already regularly produced products for land cover mapping, for biogeophysical parameters retrieval, some reference data, the satellite stuff. And you can find in the portal there things that, so products that look at vegetation, so forest, grassland, agricultural land, and these cover various topics, and you find data, different spatial resolutions. So this is the example for the leaf area index, going from 10 meters with the daily temporal resolution. This is also interpolated and smoothed to larger scale studies. So if you're looking for data sets that are regularly processed and present and cover large scale areas, this is probably one of the best place to go. And what is then the difference between what we do and what is produced there? Well, I mean, we made a step further. So we take the leaf area index, and this is used in evapotranspiration modeling, using algorithms that can run autonomously without compromising on the quality of the data. And in the next 5 to 10 minutes, I'm going to tell you a bit more about this. So the products we developed, we mainly look at the fertilization, so the use of chemical and organic fertilizers in agriculture. This is one a big pillar. For example, if you have an agricultural plot, field, or paddock, you want to manage the variability within this paddock according to the natural and actual variability that you have there. So you can use satellite observations to study this variability, and then you distribute the amount of fertilizer based on this variability. This is in precision agriculture called management zone map and variable rate nitrogen fertilization. So we do provide these maps so that farmers can plug into our services, obtain this map into their data management system, and perform such an application, of course, to save on fertilizer application, to reduce the impact on the environment due to over-fertilization, and in general, to be more efficient. The other big category of service, I'm moving my mouse so you can see, is the irrigation services. So lately, across Europe, across the world as well, water has become more and more scarce. And there is more attention to how much water we use in the industrial, in the domestic, but also in the agricultural domain. And here, satellite can help to, for example, understand how much water plants are using. I'm talking about the crop evapotranspiration. And if you know how much water the plants are using, you know as a farmer how much water you have to integrate with irrigation, with providing water to the plants. If we move a step further, so we go into what we call integrated water management services. Now, we are not talking about an individual farmer doing the management of a crop or a field, but we are talking about many fields together, where we want to know, for example, how many farmers are irrigating the crops, what type of crops we have, what is the water that is used in that area. And these services are more designed for water managers, for policymakers, for people who have to manage large extent water resources. So those are the services, and those are based on what we call core products. So crop evapotranspiration, water requirements, soil in the canopy water status, irrigated area maps, and so on. I'm not going throughout the list, mostly based on Sentinel-2 data. So that's the main satellite that we use. How is the system organized, and how are we connecting and delivering products to the farmers? Well, the system is running in a cloud, so it's a Docker, classic Docker container with an orchestrator where you have different models that do different stuff. So we have the Send-to core, which is doing the atmospheric connection. This block is going to be removed because atmospherically corrected data are now already available on most of the Copernicus apps. We do leaf area index, we do albedo, we do fraction of vegetation cover using biophysical parameters retrievals models. And again, here we use open source algorithms. The Send-to core is from ESA. The biophysical is also provided in SNAP. So those are the algorithms we use. So this is transparent and clear. And from this algorithm, we apply additional methods, for example, to get evapotranspiration, to get maps of irrigated areas, to get management zone maps. And those are more proprietary algorithms that are developed by the different partners of the project. One component we have is also the forecast. So we want to look forward in time. So we use climatic models to have a short-term forecast on what is going to be, for example, the precipitation. That's one of the natural water input that we get from crops. So those are some of the data we use. So EO data, weather data, data at the ground, sensors, and then of course the district geometries, so the parcel geometries. Through API, we connect. We can allow connections to software such as Quantum GIS, or to specialists. So for example, this eProfit is a company based in Australia that provides advisory services to farmers for yield estimation, and they can connect to our cloud-based infrastructure to obtain, for example, yield estimation and compare it to their data before they can stream it to the very end user, which in our case are farmers. We are looking at the parcel, irrigation infrastructure, or policymakers at larger scale. So this is a bit how we work. So let's go deeper into one specific product, which I believe is of interest for the audience. So it's the management zone map. It's one of the classics of precision agriculture. You have a set of data, you have a predefined process, you apply this process on demand, and you get your map of variability in the field that shows how a raster is transformed into a vector. This vector goes into the tractor and drives the application of fertilizer. Let's say now that you're a farmer and you have some experience and you want to use this experience to guide certain segmentation properties and how the satellite data are transformed into parcels, into uniform segments. So through the system, you can input this information and get a modification of the original map into something that fits best your requirements, your needs. So in this case, what we have modified is the minimum area of segments for the application. This is something that through the Koala API, you can trigger, and then you get something that fits best your requirements. This is just a definition. What this is a map that shows the spatial variability so that you can manage the fertilizer, but also the seeding and the harvesting in a selective way based on the variability you have in the field. So now to get this management zone map, it's a complex process. So we gather Sentinel-2 data atmospherically corrected. We transform them into biophysical parameters. We drop the data that are affected by cloud so that we only obtain or gather together the one that are really clean and effective. And also this process of filtering which data we take and which we drop, it's user-driven. Once we have the time series, we can then reconstruct, perform a gut filling so that we have a continuous representation on a daily scale of the plant growth. We look at the phenology of this specific field, and we do this pixel by pixel so that we have the start and the end. And after that, we look at evapotranspiration. So we calculate the water balance pixel by pixel within the start and the end of the season to calculate the total transpiration. So if you have this total transpiration, you will know the potential of growth of that specific pixel, and this is then transformed into a raster data, and for practical application is segmented into a vector data used in the machinery. So the process involved are happening with different triggering modes. So the atmospheric correction, as I say, this is today, it's a common thing. It's done as the Sentinel-2 data are collected. The retrieval of leaf area index is done also regularly, the cloud masking also regularly. Then we get the data. This is an on-the-fly process when a farmer is triggering the request. The data smoothing is also done on the fly, the phenology, the transpiration, and then the image segmentation. Of course, this has all to happen in a few seconds. To get such a process, you probably need less than a minute to obtain your map. How do we actually deliver the data? As I say, this is through an application programming interface. So there is a public address, web address, where you can modify the parameters. So in this particular case, I'm looking at ET, so evapotranspiration, for a certain geometry of these coordinates. This is near Vienna with this reference system, a certain buffer. The date is now. I want it for a period of 10 days. I want it as an image with a certain color map. And here we enter into the more domain-specific parameterization of this API. When you look at the ET evapotranspiration modeling, you want to know the leaf resistance, the crop height, and the wind measurement height. And those are parameters that you as a user can modify. And of course, then you need a token to get this activation. Results can be an image data or a table data that you can use to do web mapping or to serve other services such as yield estimation. Going back to the question of data and quality and validation, those are two examples of how we validate leaf area index through instruments at the ground. This has been work across the last 20 years. and evapotranspiration is validated through the use of evapotranspiration. So this is not a regular activity we offer, but has been conducted in the course of the project. And as a scientist, we do it continuously for our research and development activities. Another thing we have done was a comparison with another product available only for Australia from the 10 sites. It's a scientific network in Australia. And you can see here a scatter plot of the ET from Koala and the ET from the 10 site. And same comparison on a raster basis, where on the left-hand side you have the Tern, and on the central part you have the Koala products for the month of December. Now, the main difference is that Tern is monthly. It's a monthly aggregate, while Koala goes down to the day. So it's a product that allows you to do actual management of irrigation in the field. So it's not just historical environmental monitoring products, but it is actually a service that can help users. So the current deployment, it's so some numbers to let you know that this is operational, it's running. We are currently using 14 terabytes of disk space. It runs on demand, so we don't process all the globe by default, but if there is an interest, we can activate the processing of Sentinel tiles. We work on a Sentinel-2 tile minimum unit, and currently we are receiving about 5,000 API requests per day. And you see how this is actually also seasonally varying. Services are mostly active in Australia, and you see that this starts in November with the start of the growing season and ends in May. This is the most active period. Also, the response time, just to give you an idea, this is for evapotranspiration. So if you request 15 days of evapotranspiration, you will probably wait 1 second for the response. Some of screenshots of people who are using the services. So Il-Prophet I mentioned already. So colleagues in Italy are using this to provide data to farmers there. Colleagues in Spain are using the API to produce dedicated consultancy services to farmers in Spain, schedule it also in Australia. And we also developed a plugin so that everybody can download the products from Koala and visualize it in the QGIS plugin. Some final remarks. Why is this so special? Because we do produce products that normally do not exist, and we do it in an automated way to reduce the cost. So there is no human intervention. The computers are producing this, but at the same time, our big effort was to maintain quality and accuracy as the classic human control processes that were taking place 15, 20 years ago. So this means that we are more efficient. It is still accurate. We can scale, we can customize, and as a result, this can save cost and becoming more affordable for farmers wanting to use agricultural data. Where are we going? So the project ended in 2023, last summer. We have next 3 years, which will be a sort of transition period, the legacy construction, and we have ambition to continue working, expanding from Australia and Europe, and providing services for testing to others who are interested. And therefore, if you think that this might be interesting for you, you can go on the Koala website where you find the contacts, also a test token that can be used, for example, to trigger the services and obtain some more products. And that's all from my side. I thank you for the attention and happy to take questions.
Thank you very much, Francesco. Indeed, we have a bunch of questions for you. Actually, the first one is something that I think it was for David before, but maybe you are actually more directed to your field. Did you encounter that data made available by WEkEO to monitor, for example, soils and crops? Did it have enough resolution? Or yeah, what was your experience with that?
Depends on the scale. So if you're looking at Australian parcel size, several hundreds of hectares, 100 hectares, for example, the spatial resolution of Sentinel-2 data is largely enough. If you're looking at very fragmented parcels of an hectare or less, then probably you want to have a higher spatial resolution. In general, I would say that for what farmers can manage, so the variability that they can actually measure and manage, Sentinel-2 data is very, very good, is excellent. And having higher resolution will probably not result in a better management at the ground, because machines and farmers do not have the capacity to manage the variability, let's say, at the meter spatial scale. This would not be sufficient.
Okay, I see. So the second one, are agricultural field boundaries available freely through WEkEO? And if not, how did you obtain them?
Well, I mean, we don't actually store and obtain data from farmers. There is an API request. So farmer, or let's say intermediary company that support farmers, can stream to us the coordinates of the fields, the boundary, the JSON geometry, and then we do the processing on a cut from the Sentinel data on that geometry. So we do not collect or store data that are on the parcel boundary. However, if I might go beyond the question, in Europe, there is the Ajax system, which is the system used by farmers for reporting to the common agricultural policies, and those are data available, and you can find them from now more and more countries in Europe.
Okay. This question was also, I think, at the time for David, but you can maybe speak on your experience. Were you able to download data and just use it in a GIS program? I saw that you mentioned QGIS.
Yeah, so the data are very big. So you're looking at several terabytes of data. So normally we are not using this approach. We have not been using in the last 15, 20 years this approach of downloading the data and getting them on our computer for processing. So this is something I think not possible anymore. But we still believe that farmers and very end users might still benefit from owning the data and having the data with themselves. So if you're talking about a single parcel of a bunch of parcels, then this is, yes, definitely possible. And you can connect to such a system via an API or a standard OGG service and download the data or obtain the data.
Yes, tomorrow you will also be able to see more practical examples of that. We will have on our practical session someone who's going to present an example on how to download and do like quick analysis on using QGIS. So you will see that as well. And another one or two for you. Speaking of biophysical parameters, what's the progress in classifying water bodies and water courses with satellite data? What about soil moisture?
Yeah, so on the first two, I can't really answer. I mean, water is quite easy to classify. It depends, of course, on the size of these water courses. Regarding soil moisture, we do it with Sentinel-2 data, and we look at the combined moisture, water moisture of the canopy plus the soil and the first layer of the soil part. And we use the shortwave infrared combined with the near infrared through an open model, which is called Optram. It's a published model, so Optram, and this gives you a very good combination of canopy plus soil moisture. In our analysis and validation was very, very good.
Okay. Okay, one last one for you. We certainly have many questions. Thank you all for your questions. We will try to answer them and make them available to you. So are agricultural field boundaries available? Oh no, so sorry, this one we already did. Maybe this one. Do you know of any products based on remote sensing to track mowing and grazing activities?
We do have a project that would have been an alternative thing to present, which is called Satgrass in Austria. And this is within an European network of scientists Mod 6 called, that is looking at grazing and moving events. And there will be more presentations coming up in the next, more papers also coming up in the next months. So stay tuned and look at our work, but also the general scientific literature on that.
How would people be able to find you? Would it be through Koala or, well, I mean, Koala is now finished, right? As I
I think
understood.
you can Google my name and my university, and you should be able to find me there.
Okay. Okay. Great. And maybe, okay, one last one. What are the minimal dimensions in square meters of a farming zone to be recognized by satellite data to be useful in Koala specifically? Can Koala be used for any farm in Austria?
Yeah, we look at fields of an hectare. So we'd say within an hectare, I think it makes sense to have some data. So if you're looking at irrigation, 1 hectare is good. If you are looking at variable rate application, you'll probably say more. I mean, it's difficult to manage the variability with parcels less than an hectare. In general, I would say we are on a 3-hectare scale. So farmers in Austria have a 3-hectare parcel. So that's quite applicable also to our local context here.
Okay, great. Thank you very much, Francesco.
Thank you very much.
It was really nice. And now we'll have our last testimonial. It's David Garcia Alvarez from the Complutense University. And he's gonna tell us about his study, changing urban areas with Copernicus land datasets. David, whenever you want, the floor is yours.
Thank you, Andrea. Okay, I'm David Garcia Alvarez, and I'm gonna make today a short presentation about how to monitor land use change in urban areas, making use of the Copernicus land products. Let's see if I can. Yeah, there we go. First, I would like to introduce myself. I'm an assistant professor at the Complutense University of Madrid, and my research until the moment has mainly focused on the analysis of urban and rural dynamics, making use of land use and land cover data, and also on the modeling of these dynamics, making use of pattern-based models, which are fed or used as input data, this sort of land use and land cover data sets. One of the most important results of the research that I have done until the moment is this open access book that you can see displayed on the screen, which provides you a general review of all available global and continental, also for Europe, land use cover and data sets worldwide. You can find details on how to access to them, which are their characteristics, etc. Also, the book provides you with a few practical exercises to validate and analyze the information that these land use and cover data sets provide, and which will be something similar to the thing that we will be doing here in this very short presentation. Well, when we want to monitor land use change in urban areas, we will usually come with a first and important question, which is how do we do this, or which data do we need to do this? To answer this question, we have two potential answers or two potential options. The first one would be like to do our own developed data sets, to create our own data sets. In that case, we would have the advantage that those data sets would be fit for our purpose, but however, you have a main disadvantage, which is the quantity of time and resources that these require. On the other hand, we can make use of available standard data sets that are useful for many different purposes and are created by initiatives or institutions like Copernicus. The main advantage of these data sets is that they are already validated, and also they have been already tested by different users. So this experience of other users can provide us with a lot of information on how to use these data sets. Also, because they usually cover large areas, they allow for comparability. In the case of Europe, or for European urban areas, the most relevant land use covered products that we have currently available are the ones that are produced in the context of the land monitoring service of Copernicus, which are also available in WEkEO, so you can download them through WEkEO, or also you can try to analyze and make computation things in this cloud platform of WEkEO. Today here, I'm gonna focus on three main of these datasets that I think they are the most useful to make the analysis of land change in urban areas, which are the core inland cover, the urban atlas, and also the high resolution layer of imperviousness. However, there are many other products available, which you can see displayed in the screen as well, although they usually provide less thematic detail and also they are usually less accurate. You can get information about all them in the link that is provided here in the presentation, which you will have available at the end of the webinar. Trying to go through each of these three datasets that I've previously mentioned and trying to see which information they provide, I'm going to focus first in the current land cover, which we could say that is the most famous land use and land cover dataset today available in Europe. It's a dataset that allows us to differentiate between different categories of land use and land cover. Like, for example, it allows us to say where there is a residential area, an industrial area, an urban park, etc. It's especially convenient or good because of its spatial and temporal coverage. This means that it covers most of the European Union and most of the European territory, and it covers since 1990. In this way, we can use Corinne to study any relevant European settlement or urban area since that date onwards. However, the main disadvantage of Korean land cover is its coarse thematic and spatial detail. In this way, when we use or analyze urban dynamics with Korean land cover, we can get a general perspective, or we can get an understanding of the general trends in terms of urban dynamics in Europe, but we cannot really focus on the details. For this, we would need to use the urban atlas, which is quite similar to Korean. It also differentiates between different land use or land cover categories, what is industrial, what is residential, what is an urban park, etc. And also it gives us some information about land use intensity. In this regard, it differentiates, or it has several categories that allow us to differentiate between different grades of urban fabric density. In terms of spatial detail, it's 10 times more detailed than Korean land cover and also provides more thematic detail. It differentiates among 17 different artificial categories, whereas Korean land cover only differentiated among 11 artificial categories. However, the main disadvantage of the urban atlas is that it's only available for the European functional urban areas. So if you want to monitor any urban dynamic in any area that is not inside a functional urban area, you should use another dataset. The final dataset that I will be using or commenting and presenting here today is the high resolution layer of imperviousness. This is a layer that informs us or provides us information on which is the degree of sealing or imperviousness of the European territory. In this way, it informs us about land cover and how the intensity of the land cover changes with the years. However, it's different from Corinne, and it provides different complementary information to Corinne than the urban atlas because it does not focus on land in use and it does not provide information on the land in use. However, it's very detailed, its spatial resolution is very high, and it's also more frequently updated every 3 years with respect to the 6 years of Corinne and the urban atlas. In the 3 cases, the Korean, urban atlas, and also in the high resolution layers, you have layers of changes which are viable to study or monitor land change. This is quite important because if we want to study land change, we should use these layers of changes because they are treated to avoid for any technical error, any uncertainty, and also they provide more detail when studying land change. So we should use these layers of changes, but know the status layers, comparing them for the different years. All in all, what we have here, there are 3 different products that allow us to comprehensively understand urban dynamics by providing complementary information at 3 scales of analysis, from the coarser one of Korean land cover to the finer one of the urban atlas and the high resolution layers, with the higher resolution layers providing complementary information to the other 2. We can use these 2 products also, and this is quite interesting, something that I've been working with in the last years, to make validation exercises or to do this sort of fine scale profile analysis of other land use datasets. For example, I can assess the quality or the uncertainty of the core inland cover dataset by comparing it or trying to make an analysis with the information provided by the higher resolution layer of imperviousness. And I could do or I could use any of the other three datasets to, for example, validate or understand which is the information contained in any national renal product or even in datasets that are created by yourself. Now, I'm trying to connect with what you will be seeing tomorrow. I will explain you through a practical exercise how you can get access to these products and also how you can analyze these two products for the case of the studying the urban dynamics of Madrid. To this end, I'm going to share my screen. Okay. And I'm gonna, although you will see this more in detail tomorrow, I'm gonna explain you how you can get access to the WEkEO data viewer to this data. To this end, you get to the WEkEO data viewer, then you press in this plus button, and you can look for the, for example, coin land cover dataset. You add it to the map. You can see it on here. So you can see the information that it provides, also the legend, and here you can download it. As I told you before, it's quite important that if you study land change, you work with the layer of changes. In this case, the Korean land cover change layer for the period from 2012 to 2018. And you choose the, for example, year package format, you request the data, and you move to the jobs tab, and you can find here the file that you can download. Because we don't have a lot of time, I've already downloaded the information for the other datasets. What we download from with the WEkEO service is a zip file. So the first step would be to unzip these files. Once you unzip those files, you can upload them or you can load them in QGIS, for example. And here I have all the information that I just downloaded. In the Urban Atlas, you have them, you have a layer with the boundary, or in this case, the Madrid functional urban area, and also you have the layer with the changes provided by the urban atlas. You also have a layer with the changes that the core inland cover provides, and also we have a raster file for the changes of the high resolution layers. As you can see, I have already the three layers clipped or with information only available for the case of Madrid, because I've downloaded these layers and I've already clipped them. And also in the case of the high resolution layers, because they provide a different layers for every 3 years, whereas the core inland cover and the urban atlas is available for every 6 years. What I did was to combine the two layers that I've downloaded in just one with the raster calculator. We don't have time here to go through all these steps, but in the materials that you will have available at the end of this webinar, in the presentation that I did, you will find a lot of slides with all the steps that you could follow to do this clipping exercise, to download the other two products, and also to make this combination or union of the two raster layers. Well, the next steps, once we have the layers that we can use to study land change, could be to really understand what they mean or how are located in the space those changes. To this end, we need to symbolize those layers, and to symbolize the layers, we can make use of the information or the symbolization layers that are already provided by Copernicus when downloading these products. For example, for the case of the urban atlas, if we go to the properties of the layer and we go to the symbolic tab, I can try to load the style that is provided by Copernicus. So here it's, well, in the folder that we download, there is another folder that is called legend. And in the legend folder, there is a file that allows us to symbolize all changes, as you can see here. So now, once I've symbolized the changes, I can really see that, for example, in this case, what I have is a new green urban area that there was not before there in 2012, and it's now in 2018. I should follow the same steps to symbolize the core land cover layer, but in the case of the high resolution layer, because it's a raster file, I need to do a different procedure. I go to the assembly tab, I need to choose the render type, which is the palette unique values, and then here in this icon, I load the color map. I will look for mine, which I have here. Sorry. And you can see here the information that this slide provides you. In green, you have displayed those areas that they do not change at all in the period of analysis, whereas from yellow colors to red colors, you find in different degrees or percent displayed those areas that have a higher degree of imperviousness regarding what was the status in 2012. The next step is once we have the symbolization in what we can create our own maps, etc., would be to get a summary of the statistics of the main changes that happen in our study area. To this end, we can make use of two main tools, which are in the case of QGIS, for the raster layer of the high resolution layers, the raster layer zonal statistics. Okay, I open this tool, the raster layer zonal statistics. In the input layer, I choose the high resolution layer. In the source layer, I choose the same, so it's quite easy. I could save the result. When I run it, I could obtain a table from which, if I order the values of the first column, I get a list of the values of the raster. Minus 100 would be that there is a decrease of 100% in the degree of imperviousness. 0 would mean that there is not change. And for example, 50 or 30, 50% would mean that there is a change of or an increase in the degree of imperviousness of 50%. Then in this table, we have another column, in the second column, the M2 square, which reflect us in or show us in square meters, which is the area affected by this change. And in the count is the third column that is interesting for us, that provides us an information of the number of pixels affected by this change. We can export this table to our Excel, and that way we could really work, understand and analyze and try to create graphics of all that change according to the high resolution layers. Then the other tool that we can use to summarize the changes and get this statistical summary of changes in core inland cover in the urban atlas would be the aggregate tool in QGIS. Because it takes a bit of time to fill this tool, I already have it here prepared. So for example, for the core inland cover, we have to decide which is the field that we use to make the summary or the aggregation of the data. In this case would be this change field that summarizes summarizes for the core inland cover, which are the main transitions that happen. Like for example, transition from urban fabric to industrial area. Another transition will be from construction sites to urban fabric, etc., etc. And then I design here the table that I want to create that tell me which is the transition, which is the code of each transition and description of each category involved, and then the most important data here, the number of polygons that are involved in each transition and also the area involved. I could save the result here. I'm gonna run it, and what I get is a new file that if I open them attribute table, it gives me an idea of all or a summary of all changes that have happened in my study area according to this data. For example, the most relevant change for the case of Madrid in the period that I've analyzed is the change from construction seats to the discontinuous urban fabric. If we repeat the same process for the urban atlas and we, as I said before, export the three tables to Excel and work with them, we could get something like this. That allows us to, as I said before, make an analysis at three different scales and level of details of the urban dynamics of Madrid, getting a general overview and a contrasting also perspective of which have been the changes that have happened in our urban area or in general in the urban areas of Europe. We don't have time here, but then we could use all this information to compare the data sets, see if there is any error in one of them, etc., etc., etc. So this is all on my side.
Thank you, David. Thank you very much also for the short demonstration at the end. And we already have certainly a few questions for you. So the first one, I don't know if you have any information on this, but since you have been working with Corinne, maybe you would have last update on Corinne's land product was in 2018. Are you combining any more fresh data for more accuracy to time now?
I'm not sure about the question, but it's true that in the last update, well, in the new update or new way of producing Corinne from 2018 onwards, they are created a new structure of Corinne in which they are combining many different data sources that are available in Europe from different institutions and also from open data sources to create a sort of data box where you can get a very detailed perspective of which are the land use and covers in Europe, and from that information they will be creating a new foreign in the future. I'm not sure if that's what the that is asking.
The question, yeah, me neither. Also, in terms of the updates, would you know if there's something planned to update this product? On my side, I don't have any vision on if the product will be released more recent time or not. But
No, actually, it's a nice question because, yeah, the last data viable is 2018. We are already in 2024, and Corinne is usually updated every 6 years. Or every 6 years, the information that I have is that this year they are producing this version, so it will become viable soon.
Oh, perfect. It's very good, actually. There was a few questions related to that, actually. There was a question about the geographical resolution. So are there data available for Africa as well? And is it, oh, maybe that's more general question, or I don't know. Well, if it is a
Yeah.
general question.
Yeah, actually, I mean, at the beginning of my presentation, I show you this open access book, and that open access book, you have a review of all available data for global scales and also for continental scales. In case of Africa, there is not really, at least there I know, any specific land use data set like the one that we can find in Europe, just mapping Africa in detail for urban covers. But however, there are many global data sets that give you information about urban covers without thematic detail. They usually only provide a difference between what is urban, what is not urban, and also maybe the degree of siltiness of the soil. But yeah, you can use those to study African dynamics.
Exactly. And yeah, like we mentioned throughout the webinar, of course, it is Copernicus is a European program, so we do tend to focus more on European region, although we do also include global data, but maybe with a little bit less resolution and with less detail, yeah, as you said. So update again, we answer to that. Fortunately, it's going to be updated soon. And about coding a land product again, change layer only shows on land use. How do we know what change is?
Well, that was in terms of display. When we displayed, we used the last cover or the land use that was, I mean, what we are seeing is the change, no? So we are seeing the use that is in that case, or in the case that I presented, it was available for 2018. However, if you go to the attribute table of the data, you will find information about which was the old use and which is the new use. And then you can try to make your own analysis, and also you can try to make your own cartographic display with the information that you want.
Okay. Another question, for land use dynamics in rural areas, which dataset would you recommend to complement Corinne?
Well, this is a nice question. It depends on the rural area that you are working, because, for example, as part of Corinne, you have also other land use datasets available, like the one that focuses in the Nature 2000 areas, and also you have one for the riparian zones, etc. if the rural area that you want to analyze it's not covered by any of these products, you should refer to Corinne, and also maybe you can use the high resolution layers, and also you can try to create your own map based on Sentinel data. And well, this would require time and resources, but yeah, there is not something specific at the European level focusing on all the European territory. But it's important to know at this point, and I would like to also remark that the new version of Corinne that I explained before, it will be quite more detailed. So it will provide data set with like this box data set, yeah, complementing many different sources of information that you can then use to create your own map.
Okay, that could already solve that issue. So have you used both Sentinel-1 and Sentinel-2 data by incorporating each data for the classification?
Well, I've mostly worked with Copernicus data that have been already produced by the European Environmental Agency or the other people. So I have only used Sentinel data to produce very simple maps and not specifically for urban areas. So yeah, I think that you can use it to improve the classification. But definitely this the Copernicus products, this urban atlas, the Corinne land cover, etc. I would say there are products that have been produced, investing a lot of time, resources with a lot of experts. So it's quite difficult if you don't really have a lot of knowledge, expertise, and also resources to get something similar just by classifying remote sensing in my area.
Another question, how was the imbalance related to land use and land use change classes handled in this project?
Well, in my main work and where I mainly research until the moment has been to work with different data sets to see which complementary information they provide. So in this case, having a different number of classes, or this imbalance in the number of classes, is something that we already take for granted, because we already know that we are working at different scales, and our purpose is to understand from different data sources the different information that those data sources provide. So we know that we have some data sets like the urban atlas that provide us a lot of detail and thematic detail, and the other one no, but it's something that we already recognize and allow us to provide these complementary perspectives.
There's someone asking if the codes that you use, if you used any coding programming, if they are available, or if that's open, or if it's your part of your research.
If you refer to any code programming, I didn't use any code programming. Where everything that I did here, which was like something very quick, it has been done with QGIS, and in the materials that you will find available at the end of the presentation, you will have all the screenshots and all the steps detailed, so you can follow very easily all the steps.
Oh, that's great. So you would be able to maybe read to a small exercise like the one you showed. That's great. Thanks a lot. And again, I don't know if you would know this one, but are there any initiatives to further detail the vegetation types on the land use maps of Corinne land cover?
I would say that as part of the new Corinne, there will be like much more information that will allow to characterize each land use and land cover in detail. For the specific information of the vegetation types, I'm not sure, but I'm sure that there are and I know there are other land use products that specifically focus on vegetation. They are available in raster data, so you can combine the information provided with Corinne with the information provided by these other products, and you can get more detailed information of what each land use or land cover in terms of vegetation means in Corinne.
And one last one. What about the uncertainty for land cover class? Do you use dynamic world? Dynamic world. I don't know what it is, but maybe you do.
Yeah, it's another land use dataset. Land cover dataset.
Dynamic world would provide a probability for each land use class.
Well, the approach that I usually follow to assess the uncertainty of any land use or land cover dataset, it's usually like I work with dataset that have been already created to do this cross-scale comparison. So I have some dataset, and we, especially in Europe, have many different land use and land cover datasets. So we use the most detailed ones to assess the information that is provided by the Corsair ones. But of course, if you do or your team your own land cover dataset through remote sensing, and you do your own making these probability products, it's quite interesting because yeah, it provides you some sort of information about the accuracy of each class.
I can imagine. Okay, now it's the last one. Thank you all, everyone, for all your questions. It's really nice. What about the update of HRL?
I'm not sure, but I would say that it should come also this year, around this year. If you go to the Copernicus website, you should find the information of the last updates of these products. I think, and that most of them they have been already produced, but they are like making the final checks and validation exercises before they become available.
Okay, thank you very much, David, for your presentation as well. It was very nice. Thank you, all of you three, Francesco, David, and David, for your presentations. That was really nice. Just before we leave, I would just like to remind you that all materials and the presentations of our guests today, they will be made available to you, so you will be able to have more information on their research, their work. And just to give you some information for tomorrow's session, tomorrow we have a practical session. You will see a brief demonstration of the WEkEO viewer. So you will see how you can visualize the data available in WEkEO. You will then see 2 examples on how to use the data, both using Jupyter programming language through Jupyter notebooks, and using a the QGIS software as well. Now I will just show you a little bit of the platform that you have been following. If you are following online, you had to register, and you have seen the website. You'll see that at the top. Sorry, I'm not sharing my screen yet. There you go. So you will see that at the top bar, you will have different tabs where you can access the agenda, for example, of the event, more about the speakers, but also you will be able to access 2 tabs dedicated to the practical session, one to the Jupyter notebooks and another one for the QGIS session. Here you will have the guidelines that you can follow to be able to, for example, download QGIS, and then also download the practical tutorial that we will talk a little bit about tomorrow. So feel free to explore these 2 tabs, and tomorrow bring your questions. We'll have our experts ready to answer your questions. And once again, thank you very much to you all, and have a rest of a good day, everyone. Bye-bye.